Hello, welcome to the fifth unit of operating systems. In the previous units, we tried to understand what processes are. We tried to see how processes interact with each other. We saw how multi-threading, multi-processing works. We defined various inter-process communication methods and so on and so forth. What we can understand so far is that an operating system basically has a lot of different processes which are simultaneously running, and it has a limited set of resources. If we think of our regular personal computer that is at home, we can understand that it has very few resources. Here resources could be printer, RAM, the monitor, keyboard. If these are the resources, then we can say, okay, there are these many processes running. How are they using these resources? And when they are using these resources, what are the other processes doing? On the screen, we can see multiple processes running. They are simultaneously using the screen. They are giving out some output, and that output is being reflected on the screen. Not much of a problem anyways. But if we have a printer, for example, the printer has to print one specific thing at a time. We would not want two processes which are trying to print simultaneously to overwrite each other. We do not want one line of one document followed by one line of second document. We would want the documents to be printed separately. Even these resources are easy to manage. You can say, okay, for this resource, it has to be sequential entry. Whoever gives the request first goes first. But what about RAM? RAM is regularly used by every process. Process resides in RAM. Now, some processes share a RAM space, a small reserved space in the RAM, which can be written by other processes or which can be read by other processes. In that case, how are processes accessing that resource, that small memory space? We have to be sure that when you are accessing such a space, you should not be conflicting with another process. So, whenever a process tries to access one of these resources, it should be allowed to tell all the processes that currently I am using this resource, others should wait. This problem of having a critical area of RAM, a critical resource in general, sharing of a critical resource, this problem is called the problem of critical section. We do not want processes to simultaneously access a particular resource, and the accessing of this resource is the critical section. And the part of OS that deals with this is, or rather the concept of OS which deals with this is the concept of process synchronization. So, in this unit, we will primarily look at the concept of process synchronization and understand all the related concepts like critical section. We will introduce critical section in detail, and we will find out solutions which ensure consistency. By consistency, we mean that data that is written by one process should not be corrupted by another process. So, the data that is being put on that resource should be consistent with what the program expects it to be. We will see multiple solutions of critical section problem. We will see why it is such a big deal. Also, we will see what would happen if processes wait for resources. If a process has blocked a resource telling all other processes, you cannot access a particular resource while I am accessing it, then what should we do? Do we want the CPU to continue waiting without going to other processes? Or do we want it to optimize the time the CPU spends? So we will see how the waiting time can be reduced, how the CPU waiting time can be reduced. Now, CPU waiting time in this scenario is one big problem. See, if there is one process which is accessing a certain resource and it has blocked that resource, there is another process which is just trying to access that resource. What should that process do? Should it have a while loop checking when this resource becomes available, I will access it? In that case, every time that loop comes up, every time that process comes for execution, it will execute a conditional statement, check whether this resource is available, and then it will, the answer if returned false, it will go back. Whenever it's scheduled next, it will come back and ask the same question and then go back. This phenomena of continuously checking whether this resource has become available or not is called busy waiting. CPU is executing that conditional statement and it is waiting for the resource to become free, and that is not a very productive technique. We should come up with better ways of informing the next process that the resource has now become available, and then that process should be allowed to continue. Before that, the process should not even come to the CPU. So we will see how this is implemented. The method is semaphores. We will see what that means and how it works. We will also look at classical synchronization problems. If there are multiple processes working with multiple resources, each process waiting for some resource which is being used by another process, which is waiting for another resource, you can see that this can lead to cycle. Let's see. Let's take an example of three processes, three resources. Process 1 holds resource 1 waiting for resource 2. Resource 2 is currently being used by process 2, which is waiting for resource 3. Resource 3 is currently being used by process 3, which in turn is waiting for resource 1 to become free. Now we have a cycle. Each process is holding on to a resource while waiting for another resource to become free, and none of them get executed. So we will see how these synchronization problems, this coming up with a classical deadlock, is not very hard to do. This cycle was a deadlock. We will see how these problems arise. We will see how we deal with these problems by either avoiding them, preventing them, or recovering from them. You can avoid a deadlock. You can prevent a deadlock from happening if you detect in time that a deadlock is supposed to happen or is close to happening, or we can detect that deadlock has happened and now we want to come out of it. These are the three scenarios. We will see in this unit how processes are synchronized, what are the different methods used for synchronization, what is a critical section, how processes can be synchronized without continuously waiting while busy waiting. We will see what are the classical synchronization problems, including deadlock. We will see how we can overcome these difficulties.